My name is Ciara McCarthy. I'm the Global Marketing Director for EPS Global. I'd like to welcome you all to Bare Metal Basics, the first in our series of webinars, which are going to be moderated by Barry McGinley, who is our systems engineer for EMEA or technical sales engineer, whatever is required of him on the day. He's very versatile. So just to give you a bit of background on EPS, we're the open networking distributor of choice globally for a whole host of industries. We sit at the center of the open networking ecosystem, bringing together both the hardware and the OpenOS software to create turnkey solutions for our customers. We offer technical advice, configuration of software and hardware bundles. That's the switches, optics, cables, and more. We've been around for 20 years and we've 28 global locations, so we're never far away. So just a bit of housekeeping. We're respectful of your time, so we want to keep this webinar to around 30 minutes. So taking that into account, we're going to mute everybody just to minimize the disruption while Barry presents. And any questions that you have, you can just type into the chat window of Zoom. Barry will come to these questions at the end and answer them, and anything he doesn't get to, he will respond to you personally after the webinar. We will also be announcing the next 3 webinars in the series, and we'll also make the recording of this session available to you all afterwards in case you want to watch it again or share with your colleagues. So finally, just if anyone hasn't sent us their postal address yet, can they please do so? It's just so we can send you on our free gift. So that's it from me. Thank you for joining again, and I will hand you over to Barry.
Thanks, Ciara. Good morning, everybody, or good afternoon for some, because I know we have a contingent here from India due to the cancellation of Datacenter transformation Mumbai. So I hope everybody's well in these turbulent times. So a little about myself. My name is Barry. I'm a network engineer. Primarily worked on Cisco switches, and then for the last 2 years, I've been working in open networking for EPS. So the way it kind of works is customers will come in, talk to the sales guys, and then I'll come in and we'll talk about hardware. So we'll decide 10 gig, 25 gig, 100 gig, and then we'll look at the NOSes. That's what we call them, network operating systems, for the particular business case of the company. Then once we select a NOS, we'll look at virtual machines maybe, or maybe move to hardware and do a proof of concept with trial licenses and some trial hardware. And then we'll get to bringing in the system engineers from the NOS vendor, and then we'll work on implementation and configurations and things like that. So today, what we're actually going to talk about is the kind of bare metal open networking ecosystem. So we'll talk about the beginnings, where it came from. We'll talk about 3 foundations that are pretty important to the way this all works. That's the OCP, the Open Compute Project, the ONF, the Open Networking Foundation, and then TIP is the Telecom Infra Project. We'll look at some terminology you may have heard before: bare metal, white box, bright box, and we'll have a look at merchant silicon as well, so switching ASICs. We'll look at software. I split the software into 2 different areas. That is commercial software and open source software, and then they're split again in the commercial side. Then we'll look at the 3 areas that open networking is in at the moment. So that's data center, which it has been since 2011, carrier since 2016, they started working on projects, and now campus networks over the last year. So as Ciara said, conscious of time, so we'll push on. So in the beginning, there was Facebook. I was going to go back to 2006, 2007 here originally and talk about OpenFlow. It was a protocol that they worked on at Stanford University. And basically what it allowed to do was, so before, when we had normal switching, we had the control data plane and management plane in the one switch. The OpenFlow protocol allowed for the separation of the control and management layer, abstracted away to a controller. And then the data plane could just be bare metal switches that just transport the data at really, really quick rates. But we're going to start with Facebook. So 2009, and Facebook are offering a bunch of new services on their platform. And obviously with the image sharing and video sharing, their infrastructure is starting to struggle quite badly. So they got a team of engineers together, with a brief of redesigning everything, their hardware, their software, racks, power supplies, the lot. So it took them 2 years, and it was completed in 2011, and it's still going in Prineville, Oregon. It was 38% more energy efficient and 24% less expensive to run. Now, you'd expect that. You'd expect that at the least from a new data center. But the thing to come out of this was that Facebook, Intel, and Rackspace published all their designs. So then, along with Goldman Sachs and a guy called Andy Bechtolstein, they created the OCP, the Open Compute Project. So the OCP, the idea of the OCP was to kind of create a movement in hardware that would create creativity and collaboration, much like we saw with open source software. So you look at the Linux community out there, that was the idea behind it, to do with hardware. So the way it actually works is, if you become a member of the OCP, we're members ourselves, and any member can give in hardware specifications. No designs, just specifications. We'll say a 10 gig switch with 48 ports. Obviously, you have to get a little deeper than that. You actually have to hit 3 of 4 particular tenets: efficiency, scalability, openness, and having an impact on the open world as well. So once the hardware specification is there, companies can then give in design files for those specifications, and then products are built from the design files. So you get specifications, designs, then products, and then once we have products, they get moved to what's called the OCP marketplace. And I just want to show you real briefly the marketplace. So you'll see at the top we have products and facilities. That's individual products. We have integrated solutions. That's multiple OCP products to make an actual integrated solution. So I think in there we have spine and leaf. So say 25 gig and 100 gig switches in the one box. We have SIBA pods, which allows for software-enabled broadband access from the ONF. So it bunches all these products from the OCP together to create a solution. There's also there the circular economy. I'm not really going to touch on it today, but if you're interested in environmental issues, that's something that's quite interesting on how to reuse IT equipment. So if we go down and have a look at the products, so there's a nice tab here, products, network gear, and edge core. So edge core are the largest contributor to the OCP by a mile. So right, we've switches come up there. So the first one is a 571254X. That's a 10 gig 48 port switch. I think that was the first switch accepted by the OCP. It's actually end of life this year. 5812 now was taken over from it. But just at the bottom underneath, we see specifications. If you were to click in here, you'd actually see everything required to build a switch yourself. I wouldn't advise it, but you could. So it has all the design material, all the software material in there in different files. Okay, let me go back here. So the last part to the OCP is that they have close ties with the ONF and TIP. So the OCP produces individual products, and then the ONF and TIP put them into platforms and end-to-end solutions. So we'll talk about them now. So the ONF, or the Open Networking Foundation, founded a month before the OCP, actually, in March 2011. And it was originally to look after OpenFlow, the protocol that allowed the separation of the planes, and to promote the general benefits of software-defined networking. 2012, they started work on the ONUS project, which was Open Networking Operating System. It's actually a controller for the whole kind of ONF ecosystem, which we'll touch on in a while. Then 2016, kind of big shift in what they wanted to do, and they started a project called CORD. So CORD is central office re-architected as a data center, and the central office is the carrier's last point at which they kind of touch the customers. So this is the last point where they do their residential broadband, they do their enterprise broadband, their mobile. So you'd have walked by central offices before and not known. They're usually grim, kind of grey buildings. It's only if you looked hard, you'd see fans on the back and maybe cameras on the front. So you'd see projects, you'd see devices like OLTs, optical line terminals, broadband network gateways, switches, routers in these central offices. So that's what Chord is what the ONF call a platform, so an exemplar platform. And then within the platform, multiple projects run. So ONS is a project that would run within Chord. Stratum, their operating system, is a project that would run within Chord as well, but they have multiple platforms. They're on all sorts of stuff: broadband, mobile, edge cloud, and next gen SDN projects, I should say. So this is kind of going from strength to strength. They've reference designs now. So the ones I have listed here, COMAC is converged multi-access and core. SEBA is software-enabled broadband access. Trellis is not an acronym for a change. That's quite nice. That's spine and leaf in the central office. But these are all actually being implemented now in production networks by companies AT&T, Turk Telecom, Deutsche Telekom, and Comcast. So it's starting to become a real success. And we'll touch on it a little bit later on actually as well. And the final one is the Telecom Infra project. So this is the new kid on the block since 2016. And this is looking after mobile. So there's three distinct areas: access, that's your mast; transport is the backhaul from the mast back to the data center; and then core and services, that's your actual data center. So there's I have some of the projects listed there. Within access, I suppose the big one that's people may have heard of is Open RAN. That's been implemented at the minute, and other companies running field trials. From the transport, from the backhaul, the image to the right there actually shows a project that's fairly far down the line, and it's the open optical and packet transport. So the idea of it, if you see on the image, I know it's quite small, you'll have a mast. Under the mast, you'll have a bare metal cell site gateway with an operating system on it. Then you aggregate them, multiple cell site gateways in the aggregation router, like a 5916 from EdgeCore. And then depending on distance, you'd use a bare metal optical transponder. So the Cassini, that's from EdgeCore as well. There's other companies that make it, then into your core routers and then back to your data center. So it is an end-to-end solution. And all these products were in the OCP. So you see, it is an ecosystem, and it's kind of collaboration. TIP has an exchange, which is similar to the marketplace that I just showed you from the OCP. Okay, some terminology. So we've bare metal. So bare metal is a switch that just comes with ONI, which is a bootloader. And that bootloader allows you to load NOSes, network operating systems, on top of it. So simply, it's a bare metal, it's a switch with a switching ASIC from Broadcom or Barefoot, and it allows you to put whatever NOS you want on top of it. White box is a switch that comes with a NOS installed. So this is something we provide for our customers. It just takes one layer of decision making out of it for the customer. So say you go with Cumulus or Ocnos from IPI or Pika8, we'll install that operating system and then the license on top of it for you and package it off and send it to you. Cumulus also offers this service. It's called Cumulus Express. Just takes one layer of awkwardness, I suppose, out of it. Brightbox, just to describe Brightbox, actually, I'll explain who Acton are. Acton Group are a Taiwanese ODM, original design manufacturer, and they make switches for, if you've been in switching for a while, you've used an Acton switch. They make switches for just about everybody. And what they do when it comes to Brightboxes is they just put a different label on it. So HP and Dell would be Brightbox. So it's the same bare metal switch that you're getting, except with a logo on the front of it. And then Dell or HP will put their own operating system on top of it. Acton Group spun out their own bare metal manufacturer called EdgeCore. And there's a bunch of them out there now. And they're usually kind of Taiwanese companies. Delta, Quanta, and Celestica are a couple of other ones. So merchant silicon, I just wanted to touch on merchant silicon. It's kind of important to the bare metal switches. So basically merchant silicon is off the shelf chips. So these are switching ASICs. And last year, 56% of switches that were shipped worldwide contain merchant silicon. And they're looking at somewhere around 65% this year. Cisco, their new 400 gig switch comes with their operating system on it. but it also comes, there's an option to have it with merchant silicon as well. So that allows for companies that have bare metal or white boxes or bright boxes in their network to have operational unity and be able to use Cisco if they wanted to. And obviously as well, if you're looking at Cisco as far as how long it takes to make a switch, so they have to work on the fans, the boards, the PSUs, the operating system itself, even the metal. Whereas, so the time they can give to the switching ASIC isn't as much as these guys. Broadcom, Cavian, and Barefoot, this is what they're doing. So they produce better chips in way, way faster time. Okay, so software. So software is obviously crucial to this. So I've split it into 3 different sections. We've got individual devices, centrally managed devices, and then management and automation platforms. So on the individual devices side, we've Cumulus Linux from Cumulus Networks, Ocnos from IP Infusion, and Picos from Pico 8. And they all kind of have their own little niche. So Cumulus would be the main data center one. IP Infusion have kind of moved outside the data center, or Internet Exchange is one of their big ones. And Picos is large enterprise data centers. I'd kind of cover it. There's an awful lot more operating systems out there. I just wanted to give 3 because I didn't want to confuse too many people. Just to give you an idea of how big these are, I think 34% of the Fortune 50 have Cumulus Linux alone in their network somewhere. And the thing about individual devices is, sits on bare metal, and you do manage the devices individually. You can use automation tools like Ansible, Chef, and Puppet, and you use out-of-band management to get into all the switches, but you are individually managing each switch. Then we have centrally managed devices. Again, these are 2 different ways of doing it. Adaptive Cloud Fabric from Pluribus. You can actually manage multiple data centers once they're interconnected properly from any switch on any of the networks without using a controller. Big Cloud Fabric from Big Switch uses a controller to do this. So going back to what we were talking about earlier with OpenFlow, they've separated the management and control plane out of the switch and up into the controller. So basically, that switch that just does the data plane takes every bit of information from the controller. It doesn't really contain any brains. It just forwards stuff very quickly and takes all its information from the controller. Then there's another layer above this if we want. So management and automation platforms. So AOS from Apstra and xCloud Networks. So AOS actually allows you to design, to implement, and to manage a network from start to finish. So you can design your network, single pane of glass, commit it, see if it runs. If it doesn't run, it'll tell you where the errors are, and then you can deploy that exact design in real life, and it'll work. They've also just released a new function called Intent Time Voyager, which allows you to save 5 good configurations. And if your network breaks, basically 3 clicks of a button and your network's back up on a good known configuration. So what you wouldn't use AOS with a centrally managed device, but you would use AOS with, say, Cumulus. So sitting on top of Cumulus, now you can manage multiple data centers from a single pane of glass. Whereas before with Cumulus on its own, you can't really do that. You can manage it well enough, but you can't automate it that well. AOS will come into it now as well when we look at the open source options. So the open source options are mainly run by those foundations and projects that I mentioned earlier on. So we've got ONL, Open Networking Linux, which was actually created by Big Switch Networks and kind of gifted to the open world. And that's a foundation level operating system. So basically you have all your drivers and things like that, and you don't have forwarding agents. You put them on yourself. So it allows you to build your own operating system. You could put Sonic, actually, I'm going to talk about Sonic last. You could put Sonic on top of that as your forwarding agent. And we've OpenSwitch from the Linux Foundation. So OpenSwitch is what's called a composable operating system. So the idea here is to pool your resources, network, compute, storage, and use them as you see fit. So you don't have too many resources in one part of your network. Then we've got Stratum and Onus from the ONF. So Stratum is the operating system. What they're calling this is next-gen software-defined networking. And the idea is all of their projects, so I mentioned Chord earlier as a platform. So all the platforms are going to have Stratum as the operating system for the switch and ONUS for the network. I think they have a new one coming out called Micro ONUS. So ONUS is going to manage that network and Stratum will be the switching operating system. And Broadcom have an open source version here as well called ICOS or FastPath. And then finally, I wanted to mention Sonic. So Sonic was created by Microsoft and then gifted to the OCP again. And it's a containerized based operating system. So Microsoft are using it, PayPal, LinkedIn, Tencent, Alibaba. So very big companies are using it. And it was only big companies that could do it because it needed good in-house expertise, I suppose. But because it's containerized, you can now take the bits you need, and containers are being built all the time. So you can just spin up that container for the specific thing you need. So say you want to use BGP as your routing protocol, most of the other stacks are going to contain ISIS or OSPF, but if you don't need them, why have them? So Sonic is going to be a big player here over the coming years. And then, as I mentioned, AOS could sit on top of it because Sonic's free. It's going on top of bare metal. These are very cheap networks to build. You could actually spend the money you would have spent on your network on reducing your operational expenditure then by putting AOS from Apstra on top and from a single pane of glass managing your entire network. The hardware vendors are going after Sonic as well. I know Mellanox are doing what they call A2P support, ASIC to protocol, and Edge Core Networks are going to as well. So basically they're going to ship boxes with Sonic on it, and if anything goes, the hardware or the software, your first point of call, your only point of call needs to be the hardware vendor. Okay, so use cases. I don't want to go too deep into the use cases because we're actually going to cover them in the coming webinars, but just briefly, data center, this has gone since 2011 in Facebook's network. So the image on the right, the switches at the top are spine switches and the switches below are leaf switches. Now we're top of rack switches. So scalability wise, if you're oversubscribed, you just add a spine switch. If you need more port density, you add a leaf switch. It's really simple. Flexibility wise, say you've had an operating system running in your network on bare metal switches and another operating system comes out, maybe Sonic, that suits your business case better, you can transfer Sonic onto these boxes, no problem. So that's no vendor lock-in. And there's obviously huge CapEx and OpEx savings. CapEx and OpEx goes up and down depending on which individually managed is obviously massive capital expenditure savings. And then the more you automate, the more operating expenditures savings you're going to get. So hardware, we have a lot of bare metal in this area now, and the bare metal always comes first, and then the software comes after. So we've cell site gateways, edge and aggregation routers, transponders, OLTs, core routers are coming. Obviously, we've bare metal servers a long time, and ROADMs. And every week it seems like there's a new software vendor coming out for this, but there's guys that have been there for years doing it. We've IP Infusion, which sits on cell site gateways, aggregation routers, transponder, and I think the OLT software is out in June of this year. RT Brick are doing a large deployment with a European telco that once that's finished, we'll see a full software package for the carrier network. Exaware as well, and then obviously we've Stratum and ONUS that are going to be the operating system and the network automation manager of choice for every project with the ONF. There's some successes from the ONF and TIP. Most of the ONF successes are SIBA pods, software-enabled broadband access. Trellis is in Comcast's network, and Comac as well. On the TIP side, the successes have been Open RAN and a lot of field trials running at the moment with optical transponders, so that open optical packet transport that we looked at earlier on as well. So the final use case is for, hold on, move this, is for campus networks. So for anyone who doesn't know what a campus network is, so we have a LAN, and above the LAN is a MAN, metropolitan area network. So the campus area network, a CAN, sits in between the two. Basically, it's a bunch of LANs linked together over a geographical distance of, say, 1 kilometer to 5 kilometers. So if you can see the image in behind, I know it's a little awkward. We have 4 LANs, and we have them aggregated together in the center, and then out to the big bad world and the internet from the core. So those LANs, 4 LANs, could be separated by a mile or two. So you think government buildings within a kind of city center, think college campuses is an easy way of kind of thinking of it. So the way this came about was Cumulus Networks building data centers for enterprise customers, and then enterprise customers coming back and saying, can you build our enterprise network with the same gear? And while they could, they had to add a bunch of new protocols. So spanning tree, because you don't use that in the data center, multi-gigabit, port security, things like that. So, but they went off, they've done it over the last year, and now they're releasing their Cumulus campus networks. So what it'll do is allow customers who already have their data centers managed by Cumulus to actually use the same automation and management tools across their entire network, which is obviously going to be easier for network engineers. So that's your lot for today. The next couple of webinars, we have a webinar with Apstra in the States on April the 9th. We're going to have a much deeper look at hardware with EdgeCore at the end of April. And then we're going to look at an implementation of a data center solution with Cumulus at the end of May. And for anybody who wants any more information on this, there's a bunch of blogs on our website at www.epsglobal.com. So there's one on creating the modern campus, a guide to open networking operating systems, life on the edge, open networking. So there's a bunch of stuff there for people if they want to read and learn some more. So that's it, guys. Thanks very much for your time. I appreciate it. I'll hand you back over to Kira.
Thanks, everybody, for dialing into the webinar. Today, we don't have any questions, which either means that Barry did an excellent job or everybody's feeling a bit shy this morning. So I hope everybody enjoyed today. As you can see, we have 3 upcoming webinars in the coming months, and these will continue on a monthly basis. So we hope you can join us for our subsequent webinars. If you have any questions about anything today, please don't hesitate to contact Barry there. There's his contact details on screen, and he can answer any of the questions. Also, if you have something that you would like him to focus on in future webinars, don't hesitate to let us know. We have recorded this session, which we'll make available to everybody on the call in the coming days. So again, thanks to everybody, and we hopefully will see you next month at our second webinar. Thank you.
Thank you. Bye-bye.